first, a practical announcement. The company I worked for almost 20 years was called OMP, OM Partners. Recently, we renamed to OMP. That's how most of you call us already, so that's fine. Do you have any idea how often you have taken a breath since the start of the seminar? I guess not. Do you know what your current heart rate is? Probably not, unless you have any device which is measuring that. Do you know the level of stress hormone in your body at this point? I know mine is high because I'm in front of all of you. But now, imagine that you would have devices who can capture all of that information, and they exist, the technology is already there. Then what would you be able to do with that? Not a lot, because our conscious mind can only handle 4 stimuli each second. Now, luckily, we have something very powerful in our human body, which is called the subconscious mind. And the subconscious mind can handle around 20 million stimuli per second. So it can diagnose whatever is happening with your heart rate, with your breathing, and then make autonomous decision. So it's autonomously making sure that you're breathing, that your heart is pumping. And the reason why it's doing it, people say that it's because then your conscious mind can focus on the more important things. Now, I must say, I don't know a lot of more important things than breathing and having a heartbeat, but you get the point. Okay? Now, imagine a couple of years in the future that this is what would happen in your factory. All kind of devices gathering a lot of data. How will you be able to manage that and to make sense of it? I give you a spoiler alert, you will not be able to manage that and to handle that with your current way of working. So that's what I want to explore together with you in the next 25 minutes, how you will be able to handle that. Okay. And in that part, I will focus on the theme, which is of the seminar, Mastering Our Processes. One of the main processes, of course, supply chain management. Getting the raw material in, making your boxes, shipping them to the customer. Yeah? Okay. Before I do that, I think you should always consider this in the right kind of framework. And the framework is you need to have a strategy in place. Strategy means, where do I want to excel? These are different dimensions of competition. You want to be good in all of them, but you cannot excel in each of them. You'll have to make choices. And the fact is, in the future, you will still need to have a business strategy. It will become even more important because otherwise you would get lost in the amount of data that you will gather. Next to that, once you have your strategy in place, you need to make sure that you have a so-called strategic fit. Everything is aligned with that strategy. Your processes, your people, your machinery, your systems, everything should be aligned to make sure that you still satisfy your strategy. Okay. Another framework, which is one I will be using throughout this talk, is the different levels of decision making that you will have. And further down, I will concentrate on which levels can so-called smart planning help you in that perspective. First of all, there's the execution layer. You need to make boxes, you need to buy certain raw materials, make your boxes, ship them to the customer, make sure you get paid for it. The whole execution part. We all know that. Next is response. A lot of things happen, disruptions, events happen. How should I respond to that? Has to do with the customer is asking me, can I have my 5,000 boxes next Friday? Yes, I can. Making sure that you can say that in a reliable way. Okay. And then all things that might happen, machine breakdowns, all kinds of things that happen that disrupt your planning, make sure that you are able to adjust for that. And we as an industry, we're very good on those two levels. Where we see that we're lacking a bit is more on the optimized level. And this really is a complex puzzle. What kind of product should we be making? What market should I be in? What should I keep on stock and how much should I keep on stock? What's the mission of each of my plants if I have multiple plants? And then you talk more value optimization instead of volume optimization. I want to get most of the value out of my company. The highest level design, that's a strategic level. should I invest doing merger and acquisitions? What would happen in that perspective? How does it change my complete production network? But also you could consider so-called stock keeping unit rationalization. Why should I be working with 8 paper widths? What would happen if I run with 4 paper widths? What's the value of that? So these different levels of decision making, I will refer back to them at certain points, because it is important to know that certain levels of decision taking could be done autonomously by systems, but certain things you still need human knowledge, the conscious mind. First of all, let's look at some market challenges. Mr. Kling already mentioned a few. I only gonna name 4 where I see that they will have an impact on the industry. You all probably know a lot more. First one is our customer is asking more and more a high service level. But we are faced with a situation where there's variability in demand and fluctuating production rates. What does this mean? Variability in demand. I don't really very well upfront know what my customer needs, how much he needs, and when he needs it. And then with my production equipment, I don't even know very well how long it will take. That is a huge challenge, of course, from a planning perspective. Yeah? So you could make decisions there on the design level to invest in overcapacity or invest in flexible machines, quick setup, and so on. Yeah? On the optimized level, you could say, let's keep certain items in stock and manage them as stock, because it will help me on the response and execution layer to be more proactive. Okay. Another market challenge would be, and I think we all know that, it's getting shorter lead times and smaller order sizes. Yes, they have an impact on my trim, and my planning on the response layer is getting very, very complex. But again, what could I do at higher levels? I could again say, maybe I should keep some stock. Maybe I should reserve some capacity for orders which come later, or the small volumes, batch them together. There's a lot of market dynamics. Mr. Kling already mentioned personalization, individualization, e-commerce. How will that affect the industry? And what kind of decisions will I have to take? And then you see the impact of digitization. I didn't just call it digital. It's not only about the technology, digital printing, we'll come to that. But it's about the whole digitization, all of these devices which are capturing a lot of data and trying to make sense of it. Yeah? And if you see these market challenges coming, then with the current processes, the current way of working, it will be very hard to make sense of all this and to handle these. Now let's look at some technological innovations, because technology is not standing still either. So if you look at technological innovations, you could consider modern corrugators. Faster, wider, whatever. On the execution layer, they have their own challenges. You need to have a more frequent paper changes and so on, more stacks coming out of the corrugator. On the response layer, trim might become an issue, because the wider the machines, the less possible combinations you have. But it's more on the design level. What kind of machine should we have? A double knife or a triple knife, 250 to 80? What kind of paper width should we have? It's also there that you should start focusing on. Okay. We see more and more automated, also high bay warehouses, both for finished good as for work in process, even paper reels. How will they impact? Probably on your machine side, you need to take into account, okay, how much capacity do I have pulling out and putting into this warehouse? What is very important on the response layer is whip control, because these modern corrugators, they're spitting out more and more sheets, and if I don't do anything on my converting capacity, where should I store the whip? It should be in these automated warehouses. But they also have limited space, of course. So I should be careful there on my whip control. Digital printing. I'm not a specialist in that, but I know that they have some impact, of course. You can also look at digital cutting and greasing. Planning-wise, becomes more simple because you don't need any tooling anymore. But as an industry, you should consider that it's becoming more easy now to make a box on demand personalization. What keeps Amazon and the others from making their own boxes, buying sheets from you and making their own boxes if this technology exists? And then how should we react on the different levels of decision taking? Smart boxes. I came across that like half a year ago, and I read some research. I don't know, anybody heard of smart boxes? The idea here is that it's a box where there's intelligence built in, which is saying after a certain while, hey, I'm standing here for too long, somebody should take action. Or hey, I'm too humid, I'm too cold, I'm too warm. Those kind of technologies, they start coming. Again, think of what kind of decisions you would have to take in that perspective. And if you can apply this technology yourself, it requires some subcontracting. Yeah. Okay. If you look into the research, then people like Gartner had they identified 3 mega trends in supply chain management. The first one is horizontal alignment. What does it mean? Yeah, you align the complete process from designing a product, getting the material in from the raw materials from your suppliers, producing it, and then shipping it to the customer. Yeah. This is getting sales aligned with production, aligned with planning, aligned with purchasing, all of that. But it goes further. It goes into connecting with your suppliers and knowing what's happening there. It goes into connecting with your customers, knowing what's happening there, and then anticipating certain things. That's what's becoming more and more important. A second megatrend is the vertical alignment. And these are the different levels of decision taking that I already talked about. Making sure that when you have your strategy, when you have optimized your sales and operations plans for the next years, that everything is aligned with it. I think there, as the packaging industry, we can still improve a lot, or there's not so much focus on that area. And the third megatrend is, okay, we see all of these challenges, now how can we handle them? We should make our planning more intelligent, more automated, more autonomous, and that's what is called smart planning. So let's dive into smart planning now. What are the reasons why? Why should you look into smart planning? I already gave you one, this massive amount of data that will become available. There are a few others. I started thinking about what are the main key factors that make a plan a bad plan, what degrade the quality of your planning decisions. The first is data. If I don't have the data, or it's wrong, or it's late, it's very hard to do planning. We all know that. Here, digitization can help a lot. All of these devices gathering all of the data, but also smart planning can help because the massive amount of data, one, you need to be able to make sense of it within your strategy, but two, still you have to detect what could be wrong data and what could be missing data and how should I anticipate for that? What kind of action should I take? A second factor, any planners in the room? Can raise your hands? Yes, very good. Actually, that's a third point, so I'll come back to that. The second is variability. We already talked about that. There's a lot of variance in my production, my machine rates. If I run this article and you look in history, I've run it 10 times, there's a lot of variance in there. It's hard to predict. But also the customer demand, very hard to predict. Smart planning can help in changing parameters, in doing good forecasting so that you can take it into account. Doing risk assessments of, okay, what could happen and how should I avoid this risk? I come to the point of the planners. A lot of times, the quality of a plan goes down because of human bias. And it's not bad will, but it's more the, we've always done it like this, so why should I do this differently now? And often you will see that planners, they can add intelligence, and with their knowledge, they can improve a plan, and that's good. We should learn from that. But often there's also bias being introduced, and that's the part that you should try to avoid. Okay. And a fourth factor is that your decision model is not, first of all, accurate, which means if your planning model is not a real life simulation of what your actual production environment is, then of course you will get wrong things out of it. Also the scope. If it does not include all of your machinery, a bad example, but if it does not include linking into your customer's data, if it doesn't include linking into your supplier, yeah, then it degrades your quality of your planning. Okay. So what are the opportunities for smart planning? First of all, the opportunity would be detecting where something is going wrong. You could think of a lot of disruptions. A rush order, a machine breakdown, an operator not coming at work in the morning because he's ill, all these kind of things, stuck in traffic, all these kind of things. Yep. And based on that, you could build an early risk warning system. think of it like early risk warnings for a tsunami or an earthquake, then at least you already know that something could happen and you can take appropriate action. Next, if you know that these things could happen, you can already say, okay, what kind of action should we take? Should we not adjust? For example, if you see that each time, I don't know, each time a machine is running slower on a certain item, then why should we keep on planning with this norm that we have if we know that we won't make it anyway, and then we're promising something to our customers and we fail that? So you should adjust and say, if something is repeating, learn from it and adjust and take action. Okay. Next, I think we've all seen it. There's probably a lot of people here who are from the age before there were smartphones. Everything is going much and much faster. So your decision taking also needs to be much faster. So one of the advantages you could have with smart planning is increasing the speed of your decision making, because that's what something what really will be needed. And then you could come to what some people say it's the holy grail of planning. We should automate everything, all the planning decisions there are. We don't need any planners anymore. That's fine. No, that's not the message. The message is that you should try, of course, to automate as much of the planning decisions, think of these levels, as possible in a good way, and keep on improving those. But knowing that certain decisions, more on the optimizing the design level, will not be taken by autonomous systems. You do not want a system to decide to invest in a machine and negotiate with the supplier itself, I assume. Yeah? Here again, make the distinction between your conscious mind and your subconscious mind. I would make a distinction between subconscious planning, which can do these things autonomously in the background, and you as a conscious planner, you can focus on the things that really, really matter, and where you can make a distinction or a difference with the knowledge you have as a human person. Okay. Now, let me take you to a steel plant. This is in Sweden, one of our customers. And you might think, steel plant, capital intensive, what the hell does this have to do with corrugated packaging? There is some similarity. The similarity is not that there are rolls going in and flat board coming out. That's not a similarity. The similarity is that they also see a change in the market. Smaller lot sizes, shorter lead times, and a lot of, call it personalization of products. They have to handle around 30,000 individual SKUs, individual products, with sometimes routings having to go over 20 operations multi-site. It's a very complex environment, which they noticed it's fairly impossible for a human person to manage all of that. So they came to us, they were the customer, and they came to us and said, can we not improve our planning processes? We said, yeah, let's look into that. And I'll bring you now the story of what has been done there. First of all, the solution we had is what is called self-tuning, self-adjusting planning. Call it smart planning. Let me explain you. First of all, you need to analyze what happened. What did we do? This means production performance, how good did we produce, and learning from that. But it also means planning performance. How well did I plan? How much was I off plan? And what consequences, or let's say, what should I learn from that? Yeah. And then I have to adjust. I have to adjust my automatic planning system in the background. Adjusting machine rates, adjusting waste, adjusting bill of materials sometimes, overlap times. This is the waiting time between two operations. I have to adjust all of these things. And only then you can come to changing the rules of your so-called solver, your automatic planning. But you don't have to do this yourself. The system is doing it because it's learning from all of this historical data and all the things that are happening. And then you go one step further. You go into a self-learning system based on the mistakes the system made, looking back at history, but also learning from the changes that the human person has made. And they're using artificial intelligence, machine learning techniques to really say, how can I, and I am meaning the automatic planning system, how can I improve from the mistakes I've made in the past and from what somebody who is more intelligent than me is telling me or is changing. So let me guide you to how that would work. For one part, you have the basic planning flow. Based on your strategy, you define your desired service level. Could be anything. Goes through kind of a solver, automatic system, comes out, human person can still make changes. And then you have these disrupting events, rush orders, machine breakdowns. You know more of them than I do. Okay. And then you get to your actual service, which is deviating often from your desired service level. So if it's deviating, you will need to have, first of all, what is called control loops, inner loops. These are the blue arrows. And what the blue arrows do, they will say, I look at what's happening, the events, and I propagate them. This means, what is the impact on my plan, on the things that happened? I know from the shop floor, from the machinery, what happened. What's the impact on my plan? I run them through, let's say, KPI monitors, so trying to make some sense of it, aggregating it to performance indicators. And based on that, I adjust my automatic planning. And the adjustment could be, if it's a small degradation, automatically through the solver. If it's a bigger degradation, you could think of a guidance system who is giving options to a human planner to say, pick choice A, B, or C, because this is what's happening on the plan, and these are the options that I see. Yeah? I always try to compare this with a cruise control system when you're driving your car, and you put it to 120, and then all of a sudden you're going uphill. And systems are detecting that, and they tell the engine to put more power, and you get to 120 again. Automatically, you don't have to do anything. And then you're over the hill, and you're going downhill, very steep downhill, and you're going too fast. The system cannot hit the brake automatically yet, suppose, in the current cars. So it will give a warning light to the driver to say, you have to hit the brakes, because otherwise we will get off the road. Yeah. Next, you have the outer learning loops. We call them the learning loops. And that is based on, for example, things that happen. We see that machine rates are deviating, so we automatically adjust the master data of our solver. It could be a person, maybe through simulations, running some simulations and then saying, I'm going to adjust the plan. You learn from that, and based on that, you adjust the rules of your automatic planning system. You could think of this like a satellite navigation system in your car. So you just put it in and you say, normally I drive 120 kilometers an hour on the highway. You always drive 130. The system is adjusting and say, as of now, I will plan with 130 because that's what you're doing. Or you could see that the system is detecting the driver always takes a different road from A to B when he goes to work. And actually, you know what? It's faster than what I thought as a system. So I adjust, and I'm just going to next time suggest this new road. Or instead of just looking at real-time data and traffic data, I know that when I leave at 6 o'clock in the morning in Antwerp and I have to go to Brussels, by the time I get to Brussels, there will already be traffic. Currently, there's no traffic, but the system knows that on average there will be huge traffic when I get there at 6:30. So it takes me a different route, anticipating for traffic that most likely will occur. So then the complete smart planning drawing looks like this. Inner loops, which are controlling and making changes, and the outer loops, which are more learning. Now, talking of this, and you might say, we need to implement this into our own factories. I would advise you a phased approach. And the phased approach is as follows. First, install diagnostics. This means what's going on in my factory. Second is predictive analysis. What is most likely going to occur? Think about forecasting algorithms, those kind of things. The third layer then is prescriptive analytics. If this is most likely to occur, what is most likely? What should I do? Give me advice. And only then you should go to autonomous decision making. I don't need to do anything anymore. The system will make the changes itself. And once you have that established, then you can go into the more advanced techniques of self-adjusting and self-learning with artificial intelligence and machine learning and those kind of things. And when we talk about this to most people, they want to do it the other way around. That doesn't work. If you don't know where you're going, you don't know what's happening, then yeah, you can apply artificial intelligence, but it will not bring you anything. Now, there's also an example in the corrugated industry. This is control tower dashboards of a Chinese factory, fully automatic. Reels come in, boxes go out. There's only a few people on the floor. Everything through automated whip, machine setups is automatic. Everything is done automatically. Planning is done automatically. This is real life. What we're currently doing there is further extending the horizontal and the vertical integration We're not there yet, but everything is running automatically and also planning and improving. Now let's look into digitization. Digitization, as I already said, it's like everything is becoming digital. There's so much data, all of these devices in the next couple of years, which will gather all of this data. What we're going to do with it. So I will focus more on the supply chain, as I said. And that's where you come into the digitized supply chain, digitized supply network, people call it. Now, what is that? That's an open system, interconnected. What does it mean? I connect customers, suppliers, all my factories, everything is connected, machines. And it integrates all of this information to make sense of it from all these different sources. But of course, still the goal is to drive the physical act of making boxes and shipping them to your customer. You still have to have this physical supply chain. Okay. So if you look at traditional supply chains, that's how you would look at it. You develop a product, you plan for it, you source your raw materials, you make it, you deliver it, and afterwards you get feedback from your customers. And there's already quite some new technology in there, like 3D printing, which is speeding up, of course, your product design. You could do quality sensing, which immediately go back from production to quality design. But the thing here is that all of these responses that you have are based on history, and it's very latent. It's like you plan on a forecast, but by the moment you start production, the forecast is outdated. So you will see a move into what is called a digital supply network, and there everything is interconnected. And everything will be talking to each other, all of these devices. IoT stands for Internet of Things. This is all these devices talking to each other. And based on cognitive learning techniques, it will adjust and it will automatically say, okay, take the example of an ink supplier. He's in the room here, so I won't give the name, but they already have automatic systems who are monitoring machine and the printing machines. And they see that, okay, some of the cartridges are almost empty. They automatically ship cartridges without anybody being involved. Think about the intelligent fridge, which is ordering the milk without you having to do anything. Those kind of things. Some people call this the digital twin, the digital supply chain twin. You might have heard of that. Okay, so what are the main characteristics? It's always on, 24/7, and you're very agile. You can react immediately. All of these sensors, you know always what's going on. But be careful. Make a distinction between real time and right time. You don't need to know everything in real time. You might get flooded by the massive amount of information. And you need to make decisions on the right time, not in real time, but at the right time. Connected community. Talk about the community. All of your suppliers or your main suppliers, all of your factories, all of your customers, even the customers of your customers, maybe supermarket chains where you see something happening and you can already respond. You can think of some examples. This gives you more and more visibility and complete visibility, end to end, from supply all the way down to customers or the box being in the supermarket or even the box being thrown away and used for recycling. Full visibility on the complete supply chain so you can see what's happening and then you can anticipate and make decisions. Okay. And a fourth one is that all of this you cannot do without some smart planning. Think of your conscious brain. You can only handle 4 stimuli in a second. You will get a lot more here. So you need to have this kind of subconscious planning. Okay. So in summary, what you will see is this digitization. The technology is already there. It's not yet implemented, but in certain industries, they're already very far. So you will gather a lot of data in real time. And you also have these interconnected digital supply chains. It will not take that long. Certain industries, they already have quite good connections between their suppliers and their customers. And they already connected again, so you can see it's a complete supply chain for all the way from, let's say, raw material, the wood you get out of the forest, all the way down to the box. Yeah. Now that is something which you will not be able to handle with the current best practices you have. So what you need to do is you need to, one way or the other, transform, go into what is called smart planning. First start off with diagnostics, what is going on, predictive analytics, what is likely going to happen, prescriptive, tell me what I should do, and only then look at autonomous decision taking at the right level. And you will see there that the autonomous decision taking will start off execution and response level, and it's more focused on accuracy. I need to make sure I make a right decision. Whereas the more conscious decisions on the higher levels, they are more focused on resilience. How do I make my whole supply chain more resilient to problems that might arise? I anticipate them and I make it more resilient. That's the goal there. And then, of course, go into the self-adjusting and self-learning. Now, in summary, this means that actually in the future, you will have to take a lot of decisions which currently you're not aware of, you might not be bothered of, and which you cannot take because you don't have all of the data available yet. So it's a bit like another visionary said a while ago, that will simplify things that you don't know of now, and you might not think of now. But I think you should start considering this already, because it could come much faster than you think. Just like a smartphone has come much faster and made quite an impact. That's it. Thank you for your attendance.